Let's do this. So today we're going to finally do a whole lecture of live coding. It's something I like to get in more lectures, but we had to do so much theory. I don't know, just the way the schedule shook out. I don't know what changed, but actually I know what changed. I moved one of the testing weeks. So we finally get to some live coding. What I want to do is write a method that's going to traverse a tree and sum up all the values in a tree. So nothing too complex, but simple enough that it can fit in a lecture, and not too complex that I have to use 2 lectures for it. That's why it's like that. Before we get into that, before we start coding, does anybody have any questions? Anything before we get going? Yeah. So it is. It's in the examples repo tree sum, week 8 tree sum, and I just pushed what I did in the previous lecture, and it'll look a little different from whatever we end up here. Make some small changes and stuff, but it's going to be pretty much the same thing. So if you poll right now, you'll have the end results of what we're going to do. To poll in Autolab, click this blue button here, and that's going to give you the latest code. You'll see this package appear with all the code from the previous lecture. If this button doesn't show up for you, which a few students in the previous lecture, that was the case, you go to Git, and then that button is right here, Update Project. You can find it in that menu. Some students in the last lecture don't have that button. That might be your question. What's up?
That won't affect create of our own personal code that we wrote, right? That would just
No. As long as, so Git's pretty smart about this stuff. As long as you didn't also create a package named treesum, then there would be conflicts. Since there shouldn't be any conflicts, it'll pull that package. It won't overwrite your changes. You have to explicitly tell it to throw away your local changes. Yeah.
I'm sure you'll go over this. Will we be doing a breadth first search or depth first search? Will we just summing things up?
So since I'm just summing things up, it's whatever I end up coding when I do it. I think it was a post-order traversal I think I ended up doing in the last one. But since we're just summing things up, as long as we visit every node, it's going to be fine. I mean, we still have to visit every single node, so it's going to be O of n regardless. As long as we're not really sloppy about how we do things, we'll get O of n. But yeah, I think, breadth first search might have a little less bookkeeping, just because you won't have the depth of the tree number of frames on the stack. But you'll have the width of the tree. Oh, I don't know. It's going to be O of n in the end. All right, anything else before we get started? Okay. Could you go over task 5? Anything specific about it? I mean, I guess. If you have a specific thing that, actually, task 5 isn't, conceptually anyway, isn't too crazy. So let's talk about it. You're using a BST to sort ratables. Oh my goodness, it's going to take forever to load. Here we go. So we want to, or no, just songs. I don't go to ratables until polymorphism, till task 7. That's when we start working with the ratables. We want to create a playlist of songs. This playlist is going to take a comparator of song, which you just wrote 2 of those in task 4. So use those comparators, stuff it into your BST in the playlist class. The playlist, hopefully this is pretty straightforward from the description. Hopefully I'm not giving too many spoilers and hints here. But the playlist class should have a BST as an instance variable, and then use that BST to add your songs. Add songs to the BST, and the BST will sort those songs according to your comparator. Our 2 comparators are sort by title, if you just want alphabetical by title, or sorting by the Bayesian average with 2 extra ratings of 3 for all the songs in your playlist. So this will take all of your songs and then give you that playlist in the order that you expect. And the crux of the homework, the bulk of the difficulty is get song list. We want to call get song list on the playlist, which what your code should do is start at the root of the BST, navigate the whole BST, collect all of the songs in order into a linked list. So that's your bulk of the task. The rest of this is fairly straightforward, creating the BST with your comparator, adding songs to it. The BST class I gave to you in lecture, like you already have that class. You can take it from the examples repo and paste it right in your project, and I won't be mad at that at all. In general, anything in the examples repo is fair game to use on your homework assignments. You already have the BST class. Don't overthink that part. But getting the song list, traversing the tree and accumulating all of the songs in order into a single linked list is the bulk of what you're asked to do on task 5. That's where you should be spending most of your time, is get song list. What's your next class? CSE 312 in this room right after. CSE 312. Web apps, intro to web apps. We're doing the WebSocket handshake today. It's good times. Any other specific questions on this? That's task 5. Get song list. That's the bulk of it. Traversing a tree and creating a linked list. All right. If there are no more questions, let's get into some coding. So this is what I want to build. I want to write a method, tree sum. It's going to take the root of a binary tree, navigate all the nodes. We just got to visit every single node and sum up the values in this tree. And I had this, let's do this first, get this out of the way. I had this set up. I was just going to do a binary tree node of doubles. And there was a question in the last lecture of, well, that's cool and all, but like for the homework, we have a tree of songs. We have a tree of references to objects on the heap. Really adds this whole extra layer of complexity. And I was like, fine, I'll make it an object. So we can make this anything we want that's going to contain doubles. Does anybody have a suggestion of what this tree is going to be? We went with thingamabob in the other lecture, so that's the bar that we have to beat. Does Autolab end question stay open even when my specific class section is done? Wait, I don't know if my brain can parse this one right now. Does the Autolab end question stay open even after my specific class section is done? Do you mean like after the semester? After the semester ends, everything's closed, if that's what you mean. Oh, for lecture question. You're not supposed to think about that. Let's not talk about it. Just do the lecture question when the question's up on the screen. Stop. Like if I ever, no, I don't want to talk about it. So let's do. Because if that starts to be something y'all talk about, I have to stop doing that, and then whoever's exploiting that is gonna not like that. Nobody has anything. I'm going with thing. We're going to do the most boring thing.
Size of pizza.
Pizza. I like it. All right, so let's create a pizza class. Private double size. Oops. Private string. I'm going to add a second instance variable to this just so we have something else to justify why this is an object. I'll do toppings. But I'm going to set it to empty string, or maybe, I don't know, if I feel like putting a few toppings on there, I'll add them. But just to have two instance variables, so we're not just doing doubles. But I'm going to treat it just like doubles anyway. And then I'm going to do some fancy things. I don't like showing this stuff in lecture, but these are nice tools if you know how to use them. But if you don't know how to use them, I've seen students get in trouble with this. But IntelliJ can do a lot for you. There's my constructor, getters, and setters, all the way we would expect. All I had to do is create the variables. IntelliJ is going to do all the rest. All right, so we have pizzas. Returns the sum of the sizes of all the pizzas in the tree. Pizzazz in the tree. I'm leaving that. And what I recommend, I guess, what can be helpful is writing the tests before writing the code. I haven't said this too many times this semester, but I always push this in 116, is writing the test first. So we're going to write the test for this method. This is why every homework document, it all starts with the testing and then the coding requirements. And a lot of the coding requirements are just implement the features you tested above, just one line. Should be about the testing. That's one of the new things you're learning in 116, how to approach code by writing testing for your own code. That's why Autolab always gives you the feedback on your tests first before your feedback on your implementation. I'm trying to push it, even though most of you still write the code first, and it's just really hard to stop you from doing that without, I don't know. I've tried things in the past that got a lot of pushback, which forced students to write tests first. But anyway, I still recommend it, whether or not anybody listens to that recommendation, which is an awkward thing at first. Writing the test before the code is a bit awkward because what are you testing? You're testing nothing. That's kind of weird to think about. But the reason writing the test first can be helpful is writing your test cases I will always argue, should be easier than writing the code itself. I mean, for some questions, it's harder. Like when we're testing the add method, of course, the code is easier than the test. But now that we're getting into more complex stuff, we're navigating trees, we're traversing trees with recursion, the code is starting to get more complex than the testing. The testing is input-output behavior. On this input, what output do I expect? Code that in a test case. That's a test case. And what this does is it forces you to think about that input-output behavior. On this input, what should the answer be? And if there's any doubt in your mind, you can go to the homework document and read up, or the spec sheet out there in industry, read up the spec sheet and say, okay, on this input, what do I expect? What does the customer expect? What does the end user expect? Write that up in a test case, and now you're defining that is what the behavior should be. If you can't write those test cases, if you can't even answer the question, what should the input-output behavior be, how are you going to write the code? Are you going to write code that handles behavior that you don't even understand? That's the argument I'll always make. I think writing the test first would significantly reduce the number of Piazza questions, the number of office hour visits. So if you're really resisting that, at least give it a try. Give it a try. Write your test first. Write really good tests first. This is the next step that I really can't get students to do. Just sit down and write really good tests. Write a really good test class. Don't just write half-assed tests and submit to Autolab and see what you get. That's what I see way too much of. The bare minimum of testing that satisfies Autolab. All right, with that, let's write the test first. We do need something to test. So I have the method here existing. This is what we call stubbing out a method. The method exists. I have the name, the whole signature defined. The name, the return type, the input type, the parameter list. But I'm just going to stub it out. I'm not ready for this method to do anything yet. So I'm just going to return something, anything. It can be anything. All its job is right now is to get my test code to compile. If the method doesn't exist, my test code doesn't compile, and I don't know where to even start. So let's start writing some tests. For this, we're not going to use a BST. I'm going to create my trees manually the way we did on Monday. So let's get right into it. I'm going to create a binary tree node for the root of my tree. And just because this repo has multiple binary tree node classes, I'm going to be careful with which one I import. I'm going to get the one from week 8, the one that I'm working with here. They both do the same thing. They're just copies of the same class. With I think the second one has less clutter. It doesn't have the traversals in the node itself. But if I mix those, if here I use week 8 binary tree, and over here I use the week Y binary tree, they're two completely different types, and the code's not going to compile. So binary tree node of pizza. I'm going to call these pizzas. Equals new binary tree node of new pizza. And I don't know what our units are, but a 10 size pizza. pepperoni. I'm not going to do all the toppings, but I'll do one right here. Null, null. Let's shrink this down so I have more room here. I did spell pepperoni wrong. I'm going to change it to pepper because I don't know how to spell. So I have a pizza with just one, a tree with just one pizza in it. And I think I'll leave this test case just like that for now. And, well, forever, I guess. And, no, let's not do that. Because then it's harder to make the next point that I want to make. I'm going to set the left of this tree to a new binary tree node. Let's say 2.4. And when we're testing with doubles here, we want to make sure we get our decimal portions in there. I'm still going to do negatives, even though I forgot my constructor call. I'm going to start doing empty strings for the toppings. Even though set right. Even though pizzas don't make sense to have negative size, I knew I'd get to the end of that sentence. It doesn't make sense for pizzas to have negative size. We're still going to test it and make sure our code does what it's supposed to do here. Man, I'm blanking on these constructors. We're going to make sure our code does what it's supposed to do, even with negative numbers input there. Just because we're working with doubles, we want to think positive, negative, very large numbers, very small numbers, and make sure we get decimal portions, make sure we're not accidentally getting integer division somewhere in there. So I'm going to test those cases. And for this test case, I'm going to keep it this kind of simple. My actual is going to be call the method and figure out what it does here. Now, this is a static method in the tree sum class. So I'm going to call it through the class itself. TreeSum of pizzas. Call my method to get my expected, and then, or to get my actual. Then my expected value is going to be some number. Now, whenever I have to compute a number for my test cases, there's two things that I don't like using. One, my brain, and two, my code, any code. I'm going to go somewhere else, in this case, calculator, and have the calculator do the work for me. I don't want to add up these. Like, I could add these up, and I'll be right like 90, maybe 95% of the time, but I'm going to have some human error in there where I add them up to the wrong value. And if I have a bug in my test case whose purpose is to expose bugs, it's not going to work well for me. So I want to limit any possible mistake that I can have here and use the calculator. 10 plus 2.4 minus 50.6. It's going to give me negative 38.2, and paste that right in my code. And when the examples get more complex, especially if I'm working with, say, CSV data, I'll go to a spreadsheet, and I'll use a spreadsheet to generate all my expected values for my test cases and generate my test cases themselves. Sometimes I'll have Excel cells where I'm actually writing formulas that'll write the code for my test cases for me and then copy and paste that all in there. Like I want a test case that adds 10, 2.4, and negative 50.6. I'll have the spreadsheet generate all this code for me, and I just input the numbers, for example. Especially like a linked list. For a tree, you have to have left and right too. But for like a linked list, I don't want to write all that code. Oh, the spreadsheet do it for me. And then my expected is computed from the spreadsheet. It makes it a lot easier. So I don't like using my brain, and I also don't like using code. Can you have multiple binary trees in one test case? We'll see that in a second. I have to. Sorry, tomato. It's just too distracting. So I don't like using my brain because I don't like having human error, especially my tests where the errors can compound. And that goes a whole nother layer when I'm writing tests to test your tests. It's this whole extra layer of compounding, anything that's wrong in any step just compounds into errors and errors. So I don't like trusting my brain for that. Yeah.
So in this example, when you have the binary tree node, all the nodes like replaced with gamma pops.
Replace with what? What was that?
Are all of them replaced with gamma pops?
Yeah, I can't hear that last word. Was
Are all the nodes like replaced with thingamabobs?
Oh, thingamabob. Oh, yeah. For the previous lecture, what I pushed to the repo, we use thingamabob instead of pizza. But yeah, it's the same idea. The pizza would be replaced with thingamabob from the repo. And 2, I don't like using code. So I could, in expected, instead of computing it, I could do 10.0 plus 2.4 minus 50.6. I can do that right here. And with this example, I'd get away with this just fine. There's not going to be much issue here. But I don't like being in this habit. I don't want this habit of writing code to generate my expected values, because at some point that code can start just being the code that you're testing. And then you're in that situation where you're using your code to generate the test cases to test your code. And it's just a cyclical dependency where your tests are always going to pass. And then you submit to Autolab and it always fails the correct solution because you have a bug and you have no way of identifying it because you defeated the purpose of writing tests. In this case, it's not that bad because I'm just adding numbers here. And in the method, I have to traverse a whole tree. So it's not quite that bad in this instance. But just to make sure I'm not developing that habit, I'm still going to generate my solutions outside of my code, whether it's a calculator or a spreadsheet, anywhere other than my own brain. That's where I'm going to generate my expected values. And then assert equals and make sure I get the right order again. Expected, actual, and then my epsilon. I have decimals out to 1 decimal place. So as long as I'm out further than that, I should be good on my epsilon. And there's my test case. I can run this. I expect it to fail, but it does run. Importantly, it runs and then fails, as opposed to not running at all if I didn't have the method. So I stub this out so it exists, so my code does compile. Then the question is, how do we write more than one test case? And here's what a lot of you do. Tell me if this is familiar. Copy, paste. And so you copy and paste in the same method, and then you go to all your variables, and you go 2, 2, 2, 2, 2, 2. Which I still do this from time to time. Sometimes it's just the quickest, easiest thing to do. I recommend not doing this in this situation. Too many times, office hour visit, student comes down, sits down with their code, says, everything is fine, I don't know. I submit to Autolab and just everything's really weird. Like, I just don't know why it's doing the things that it's doing. And I glance at their code, and of course, I've spent hours working on this, hours of your life. And then I go, you missed a couple 2s. And you go, son of a, hours of my life spent because you missed a 2. That's not a situation you want to be in. It's not where you want to be in your life. So I recommend not doing it, one, for that reason. Those office hour visits are really frustrating. I mean, it only takes a few seconds of my time, so it's not that big of a deal for me, but I hate seeing that pain on the student's face of so long just because you had a copy-paste error. If you're doing that, make sure you get your 2s everywhere. So for my money, when I do that, which I do still, I'll admit, I still sometimes do this, is paste above. I developed this habit, and it's saved me hours, thankfully. Paste above your original code. You're going to get errors because you have duplicate variables. So you fix those variable names. And everywhere else where you need to add a 2 is now an error. It's highlighted in red for you. You can't miss them. You literally can't miss them because if you miss them, it's a compilation error. So if you paste it above, easy to tell every single place. The ID highlights them for you. You know everywhere you got to hit it to. So I recommend that. It's a trick I've developed over the years. But there's a better way in this case. The one that I actually recommend, copy the whole method. Put a 2 right here, and you don't have to change any variable names. This is the much, much better, much more preferred way to do this in your test classes. Just copy the whole method and create a whole separate test for your different test cases. Unless you have a situation where like you're adding 2 numbers and it's easy to jam a whole bunch of test cases in a data structure and loop over it. Unless you have a situation like that, once they get more complex like this, copy your whole entire method and then create a new tree and do it that way. There's a few advantages to this. One, the one I just mentioned, you don't have to change your variable names and miss a 2 and waste hours of your life because of it. And 2, you get more feedback on your tests when you run them. So instead of just saying, okay, your test failed or your test passed, now I get individual feedback on each one of my tests. And I encourage this in Autolab too by giving you individual feedback on each one of your tests. So instead of failing a correct solution, when I see failing a correct solution in office hours and the student has one test method with hundreds of lines, I'm not looking through that. Split it into separate test methods. Split each test into separate test methods. And then you can at least identify, like Autolab will say, this one's good, this one's good, this one's good, this one's good, this one's failing a correct solution, this one's good, and this one's good. And you know exactly where to look. You got 10 lines to look through instead of hundreds. It can save you tons of time. So Autolab, I'm incentivizing that through Autolab by giving you that individual feedback per method. But even outside of Autolab, you're going to get extra information right here. You're not going to have to hunt down which ones passed, which ones failed. And if you have something failing very early in that test, you don't even know if anything after that passed or failed. You have no information about it. So you get a lot more information, too, when you split these into separate tests. And so let's split these into separate tests and then start writing more test cases. So my first test case, this is my really plain one. I like having test cases like this. Of course, we want to think of our common, uncommon, our edge cases, and write lots of tests. We want to do all of that stuff, and we're going to. But I also like to have some simple tests, too. I always like to have some simple tests. This test is pretty simple. We have a tree with 3 nodes. It's balanced. There's not much that can go wrong in your code here to fail this test. So if I'm failing this test, I know that I'm completely out to lunch. I know that I'm completely sunk, and I have to look at fundamentally what my algorithm is doing to make sure to fix it and make it do what it's supposed to be doing. If this one's passing and some other test cases are failing, well, now I know I have the general idea. Like, I'm okay, I'm going down the right track, but I got some more work to do on more of the trickier cases. So I want something simple as a test case, as kind of a barometer. Like, how close am I? When I run these tests, how many green check marks I get versus how many yellow X's I get, that's going to tell me my progress as I'm working on the question. So having some simple test cases can help that. And to that end, let me duplicate this twice because and I would usually name these something better than 1, 2, 3, 4. But I'm not going to think of names right here. So, so I want one simpler one too. I want a test case with just one node. This is my ultimate barometer test. Like, if this one fails, I am completely screwed. Like, I might rewrite my whole method. I might rewrite the whole code. So this should be 10. There's nothing to even add here. And it should be that easy, by the way, to add a new test case. Copy your whole thing, change the method name, change the input, change the expected output, and that's it. I'm not thinking too much when I make that test case. Unless I'm adding nodes like I'm going to do in the next one, then there's not much thinking to do. For this one, I want to add some nodes. Let me duplicate this line a few times so I don't have to think too hard. Yeah. This? Yeah. That's the like epsilon for comparing doubles. Like, we never use equal for doubles. That's handling that issue. 30.3, 9.6, and let's make sure we can handle 0.0 in there. All right, and so here I want to make a tree, and I want to make sure this tree is really imbalanced. This is going to be my tricky test case. When you're writing test cases, I like having my simple ones, but you want at least one test case that's really going to challenge your code. One that's your code really has to be correct. Not has to be, but if it passes the challenging test case, it's most likely going to be correct. So with this, I set left, set right. We have a root with left and right. And let's go get left dot set right. Let's get so we're going left and then right. Let's do it the same way on the other side. Get right and then set left. Let's get right, get left, set left, and let's go down this one more. Let's get right, get left, the node we just added, and set, let's go left again. So we got a really imbalanced tree here that if my code is getting this one, I'm feeling much more confident that my code is actually correct in this case. Let's get our calculator out and figure out what this should be. So 10 plus 2.4 minus 50.6 plus 100.8 plus 30.33 plus 9.6 plus 0. 10253. And I got another test case. All right. Let's go back to this one. So that's my challenging one. If I get that one, I'm feeling pretty good. Now we want to start thinking of edge cases. And this would have to be in the description of the problem somewhere, but what should happen when the input is null? Oops. And we'll say 0.0, right? Let's make sure we get the case where there's somebody already ate the pizza before we got there, where the sum is 0, where there is something in the tree, but the sum of all the things is 0. Speaking of, let's do that in another way too. Let's add pizzas dot set left. Let's do a tree with 2 nodes where the sum equals out to 0. Oh, we don't have any small values either, so let's do that now. 0.111, 0.0. Let's grab this. I'm going to cheat a little bit here just because I don't want to spend too much time. Like, you get the idea by now. I don't want to spend too much time just typing these out. So I'm going to steal this one, and I want one tree that's horribly imbalanced, that's effectively a linked list, and I'm going to build a linked list tree. And I'll do this a little bit different than the other ones, just because this came up in actually both lectures on either Wednesday or Monday. I think it was Monday's lecture when we were creating these manually, is we can actually do this in one statement. So I'm creating a new binary tree node in null, null, and then immediately replacing the nulls. I can actually do this in one line. If I paste my code here, I'm going to separate this. The reason why we use semicolons in Java, by the way, is that we can break our statements into multiple lines. And as long as Java doesn't see a semicolon, it's not going to treat that as the end of the statement. So I'm going to split this into separate lines to make this hopefully a little more readable. It's still going to be horribly unreadable because don't do this, because it gets really unreadable. But I'm going to set the right child, so left is null, right of the root is going to be this 2.4. To the right of that, we'll have negative 50. Oh, I regret having this many nodes. But we're committed now because I don't feel like opening the calculator again. I guess I could leave off the last one, but we came this far. So we have a linked list. Some should be exactly the same. We just changed the structure of the tree. And I have some pretty janked up looking code here. This is one of my favorite features of IntelliJ, or I'm sure every IDE has this feature. And I forget what the shortcut is on Windows, but on a Mac, I'm going to hold Control, Option, and press L. Oh, son of a bitch. It usually works. In the last lecture, it worked a lot better than that. It sometimes depends on how you have your code structured to begin with. Oh, man, that sucks. Maybe because, well, I did all to the left last time. Maybe it liked it better going to the left. Yeah, I can't get it looking good. Anyway, well, that's as good as we're going to get it. But anyway, that feature is the auto formatter. So if your code is all jacked up all over the place, the formatter is going to even it out as best it can. It didn't do super great in this instance, unfortunately, but it'll clean up the formatting of your code, fix all of your indentation, make it look a lot cleaner. I hit that shortcut all the time. I'll write really messed up code and then just let the auto formatter fix it all for me. If I have too many spaces here or something, the auto formatter is going to just clean that up. And you can set your auto formatting parameters. If you have a certain code style you like, you can set that style, and the auto formatter will enforce it. What's that? Is there, or there is? But oh, I don't know. I don't know. I don't know if Java has an official one or not, or if it's just common now. I don't know. I don't know. I'm sure there is one that's generally used. I don't know if it's published by Oracle. Why the two tests taking different amount of time to compile? Oh, that can happen. If I run this, it'll take a while to compile. Actually, that didn't take long at all, and I have an error. Maybe that's why the formatter wasn't doing it for me. No, that wasn't even in the right thing. But it'll take a little while to compile. Multiple seconds. But if I run it again, it'll go a lot faster because it's already compiled. It just has to run. So there's a lot of factors that go into compilation time. Yeah, I'm getting to debugger. We're going to do that. Closest to a pizza party, yes. It's a lot of pizza to feed all of you. All right, so I'm happy with these tests. I think this is enough testing. We run them. We just ran them. And most of them fail. We actually do have a few that pass because we have a few that expected 0.0, and all our method does is return 0.0. So we happen to get a couple of them right just by default. But let's start writing this code. I'm happy with that test suite. For production code, you can spend forever writing more and more tests, but we got a pretty decent testing code there. So now it's time to write the method. And since we already have the test, it should make it very much easier to write the method itself. Because when we write the method and we kind of feel like maybe we're on the right track, run the tests. What do the tests say? You have a whole test suite that's going to tell you how close you are to correct code. So we're just going to run them. So let's start with something pretty simple, tree.getValue. Value here is going to be a reference to a pizza object. So then I need to get the size of that pizza. And let's just return the size of the root node and run this. And when we run this one, what we're going to see is 3 different symbols in our testing. We have 3 different pieces of feedback. One, the green check mark. These are the ones that we're getting right. So we're still getting, okay, just one node. We're going to get that one right. We're going to get just one node with 0, 0. That's fine. We're going to have a lot that are failing, the assertions, and one here that's going to give us an actual error. This red circle, that's going to be a legit error running the code, which is a bit scarier. We're getting the null pointer exception. We can click the line number and see where it's happening. Click the wrong one. It's happening on this line. We're passing tree. Oh, I didn't. And it's this test that's getting a failure. When pizzas is null. Okay, so now tree is null in this stack frame. Tree dot, as soon as we hit the dot operator, that means this is a reference. Take me to the object to which you refer. If that's null, it's a null pointer exception. There's no object to go to. You can't call the dot operator on null. You're going to get a null pointer exception 100% of the time. Can't do it. So first thing we want to do here is check if tree is null. Return 0.0. Else, then we can start doing stuff. And here I want to do some checks if. So if tree dot get left is null, I'm going to return tree dot get value dot get size. Else, I want to make my recursive calls. And in the interest of time, I'm going to do this in one line. Return tree sum. So I'm going to make my recursive call. Tree dot get left plus tree sum tree dot get right. So make my recursive calls on the left and right and sum those both up. And tree dot get value dot get size. Now I want to run this code, see how I did. I don't know, maybe I'm kind of close, but I don't know. Good thing is, I don't have to think about it. I don't have to think, man, I don't know if this code's right. Let me look character for character and try to find any bugs. Hell no, I'm going to run my tests. I'm going to run my tests, and my tests are going to tell me how I'm doing. That's why I wrote my tests. And I'm doing okay. Doing all right. Let's take a look at the ones that failed. I have an assertion error that's way off. Another assertion error that's way off. And what I want to do here is still not looking through my code line by line. Screw that. I don't want to do that. I'm going to go to my test case, one of my two that's failing. I'm going to pick whatever one I want here. I'm going to set a breakpoint. This is right next to the line numbers. I'm going to click right in this kind of empty territory here. I'm going to click there. That's going to set what's called a breakpoint. And I'm going to run my test again, but I'm going to run it in the debugger. I'm going to run this in the debugger. What this does is runs my test, just runs everything as normal until it hits a breakpoint. Once it hits a breakpoint, it's going to stop everything and show me everything that's happening in memory. I put the breakpoint right at the first line of one of these tests, so nothing's ran quite yet. Nothing's really happening yet. But I can step through this and see what's going to happen. There are 5 really key buttons that I like to use in the debugger. I won't get to talk about all of them today, unfortunately, but I'll talk about the 2 most important ones, step into and step over. Step into is going to advance one line of code. It's going to run the next line of code and show me what's happening. The next line of code here is going to be the pizza constructor. Whenever there's 2 stack frames that are created on the same line, it's going to ask you which one you care about. I'm not going to choose either. You can click on which one if you're interested in one. I'm not going to choose either. I'm just going to click step into, and it should. I wish the debugger always went logically in order. It went to the binary tree node, even though the pizza constructor will be called first. But it goes into my constructor. This is a reference to the object that's being created. Value left and right are on the stack, because they're parameters. And I can drop these down. These are references to objects on the heap. I can see because of the at and number that they're objects on the heap. I can click the arrow to expand them to see the values of their instance variables. And I can step through this code, and I can watch value get populated with a reference to that pizza. And watch everything that we do in our memory diagrams. The debugger is going to show you all of the same stuff. It'll show you in a different format. For example, I can see I have 2 stack frames here, the constructor stack frame that I'm in right now, and I can go back to the test tree sum 3 stack frame, which doesn't really have anything of interest. It has a reference to a sum tests object. This is a non-static method, so that does have to happen, but that's internal to JUnit. We don't really care why, or we have this reference. Then I can keep stepping through. And once I get to a line like this line, I could step into, go to the binary tree node constructor, go to the pizza constructor again. But I'm really not interested. That's where I'm going to use my next button, step over. That's going to run the whole next line of code without going into any additional stack frames. So if I step over, I'm going to skip over all those constructor calls and see my tree being created without going into all the details. And I can view my tree. I have pizzas, which is a reference to a binary tree node at 1175. I can expand this, see its value is a pizza. Its left is another node. I'll keep this expanded. Its left is a reference to another node with another pizza. Its left is null. Its right has the value of a pizza. The root right was a node with a reference to a pizza, with a left having a reference to a node and a reference to a pizza. And we can verify that this is the tree that we expected. This will be the first thing I do when I'm debugging. Make sure the tree is the tree that we expect. I didn't verify everything there, but I'm pretty sure that's going to be right. And this was the reference 1175. If I go into the next stack frame, step into the tree sum stack frame, I can see I get a reference tree. It's going to have the reference at 1175. I know that this is the same object that I had 1175 over here. It's a reference to the same exact tree in a separate stack frame. In this stack frame, we can start debugging. We can start looking at all of our values, stepping through, and seeing what's going on with this code. Tree equals null. I expect that to be false. And go into the else. We've got into the else, so we're looking good here. Now tree, left and right, neither of them are null. So I expect this to be false. We're going to go into the else. And we're going to make a recursive call. And here I am going to choose which one we want to go into. Or else we're going to get into all these getters. I'm going to go to tree sum on the left. So now we're at the left of that node. We're to the left of the root. So at this stack frame, we're at 1175, the root.